Hey everyone, this is a quick explanation video to cover the latest version of LadyBug that was just released recently, basically a couple months ago, so in November of 2020. And all I'm doing here in this video is to actually just kind of replicate a couple of the things that we did earlier on with the legacy version and just kind of replicate some of that functionality. So if you look at the module for this week, it will be kind of titled. There are kind of two separate ones. One is the legacy version, which is what we had before. This is the newest version. You can follow either one. They're very similar. The newer version kind of cleans up the interface a little bit, and some things are kind of a bit easier to read. All right. Now, do kind of take a look before we start with the newer version. The link that's provided here in terms of installing LadyBug, follow this newest version down here. It'll take you to a GitHub site and follow, and most of you should be on Windows. So follow the Windows installation steps. And this is actually downloaded from the Food for Rhino site, and it's pretty clear what to do. So you can kind of follow that. The optional step that you will need to do probably is this, installing Radiance to be able to run the daylight and solar simulation. So you can go ahead and do this part, right? Otherwise, the first time you drop some of the components, then it will prompt you to actually come and do this, right? The others kind of depends, like if you're gonna use Honeybee, then you'll need this. If you are gonna run Dragonfly, then you'll need this, right? So this kind of eventually depends what you need in the future, okay? So there's that. The second thing probably just to kind of mention, and the overall kind of file, right, is here. I've given you the JPEG as well, and though over here, and I'm not going to rebuild this entire thing because these are actually kind of generally single components. I've tried to arrange things so you can kind of see pretty well where wires are passing through and what they're connecting, so there should be generally no overlap, or at least it should be readable. So one thing, at least in terms of saving this file, that I want to mention really quickly is that when you save the file, once you're done, you generally want to toggle all these that are connected to a run input to false, right? Because this kind of initiates, some of the calculations. And if you have them saved to set to true and you save it, the next time you open it, it will try to run them all at once. So, not that it's impossible, just like opening the file will take a couple, maybe 1 minute or longer, a couple of minutes, depending on your, computer. The components that are highlighted in blue here are legacy components, meaning that they are components that are from the earlier version. And as you can see in the documentation, they can actually live side by side. Let me see where it is here. So if you have both versions installed, right, what you'll get is like most of the ones on the left side, so they have the same number, 0, 0, right, 1, 1. The ones on the left are the newer version. The ones on the right are the legacy version, right? So the easy way to kind of tell that is that if you, let's say, plop some of these in, and then you have a legacy version component in here, it will give you the version numbers below, right? So it starts to tag them with version numbers when it gets fixed. So you'll know this is a legacy version. This is the newest version, okay? So that's just the kind of distinction. But I called these out because like these versions, these two things don't have the same functionality in the new version yet, or if they decide to port it over or it's getting replaced. But this is some stuff from the earlier versions that we found might be useful, okay? All right. So going back over here, we're kind of replicating a lot of the same things here. To begin, this is similar, right, to the file that I provided to you guys on Canvas, but it's basically assuming that the center thing is whatever your design is. in massing, right? Remember, these calculations for these things should, the geometry should be simplified, right? Otherwise, it would take longer to calculate. So the only kind of input geometry generally we have here, one is the design geometry, which is this guy, and context geometry, including the ground floor plane, right, and any kind of buildings that might be around it. This viewpoint is actually just a linked Rhino viewpoint that we'll use for the view cone analysis later on. But that's it. These are actually all just BREP containers, right? So if you're kind of making them yourself, go to params, BREP, right? It's the same thing. The reason this reads different is just because I've renamed it up here when you right click on it, right? So you can rename these just to be a bit more verbose, but that's kind of what these are, right? All right, so the first step is sort of importing a new EPW file. I know in the previous version, there are like 4 different ways, and there still are many different ways, but I think generally I found it most consistent actually just to go to the website, right? Which is this EPW map component right here. This one, sorry, the second one, they'll open in EPW map in the web browser. So it's the same sort of thing. And just attach a Boolean toggle. If you double click in the search, Boolean, right? Just click on the Boolean toggle, which gives you this sort of true and false, right? Toggle. So by default, it's false. Connect this in. As soon as you click it to true, it'll open your browser and bring you to right the map where you can click on something and just download right data. So for us, right, you might be looking at Gainesville or Jacksonville or Tampa, Orlando, whichever it is. Click on it, right, and download from DOE, which will download it as this zip file, right? If you double click into it, zip out or unzip it somewhere, you'll see you get a couple ones, an EPW, a stat, and a DDY. The one we're using is this, okay? So that's pretty straightforward. Once you download it, just link it in, right? Now, this is maybe something you might not be familiar with, but this is a file path component. So going into params, primitive, right? File path. So what this does is it allows you to link in any file. So if you right click on it, select one existing file, then you can just browse to, right, wherever things are, right? So I'm bringing in the one I provided you guys with, and you, of course, you can download your own, but this is the one for Charleston, right? And then just link this into here, okay? This guy is the import, right? EPW. So again, LadyBug in the first kind of import line right here. So essentially it's like number 2, number 3, right? Import EPW component, right? Now this goes into a couple different things, but this is just kind of collecting the data and parsing it out into different portions, right? So the first thing you should do is kind of working towards the right is the sky matrix, right? The sky matrix should be, let me see, 1, 2 here. Okay, so under number 2 for the newer version, right? You'll see like they've kind of sort of combined a bunch of things from the previous version, but this is the one, the cumulative sky matrix. Actually, you can drop both of these. So the cumulative sky matrix and the LadyBug sky dome, which is this guy, okay? And I'll show you what these are here really quick, but north direction input, right? It's a number between, minus 360 to 360, but basically assumes by default generally like that essentially like 0 is the y-axis, so up, right? So it's assuming that north is up, right? And which is kind of, normal for all of our conventions. So if you put in 0, that means north is up. Location, right, which actually comes from, right, the import EPW. If you want to take a look at what it's doing or what it's kind of giving you, if you link it over, it just says Charleston, latitude, longitude, right, elevation, it's this, right? So that information obviously goes to location. Most of these are actually pretty easy to match up, right? So the direct radiation, if you read the description, right, you'll know it's actually coming from here, direct normal radiation, right? diffuse radiation comes from diffuse horizontal radiation. Okay. Um, HOYs, or sort of our yearly component, comes from here. So this is the analysis period, right? And this guy comes from here. So under number 1 here, right? Analysis period. This is the same. This is the component you're looking for. And you can note this, that although like if you're kind of looking for an entire year analysis, by default, it just does the entire year, right? So you actually don't need it if you're looking for the entire year. Like, you'll see here on the last sentence of the description, it says by default, the matrix will be for the entire year. Now, this is also set to the entire year right now, right? So if you want to change the analysis range, right? So if you're looking at summer or winter, then you can kind of change these dates and hours, right? That's the only thing that it really affects. One thing actually just to note here is the time step component here, or input here, means that how many analysis points per hour, right? Are you going to run? So obviously, like if you do, this is set by default, sort of set to 1 per hour. So it only checks like, at the beginning of the hour. If you do 2, then it will do analysis point at a half hour, right? Or 4, it'll do it at 15 minutes, right? This is just the interval. So this, depends, right? Sometimes it's necessary, sometimes it's not, right? Depends on what you're trying to do, how granular your analysis wants to be, right? The high density component uses 2 different sky matrix models. The normal, right, is the Tregenza, which is a little bit kind of lower density, but it's faster. If you want to kind of higher density and higher grain analysis, and you have the time to run it, then you can toggle this to true. But generally, it should be false, right? Okay, so going from here, we've kind of plopped in these 3, right? So this is all just kind of bringing information in, right, up to this point. The rest of it actually comes a lot from, things that we've kind of already done, or sky matrix, right? The sky dome is more of a visualization. So if I turn it on, right? So the first time you plop in the sky matrix, it might have to kind of calculate for a little while, right? It might be a minute or 2 while it kind of generates the information based on the parameters that you're giving it, and this analysis period stuff. The very first time, some of these components will take a moment, including this one, not the Sunpath, but eventually the direct sun hours and radiation, these 2. So a couple of these, this one, this one, these guys are the ones that might take a couple moments when you first bring it in. So just let it run, okay? The sky dome is more visualization based, right? For essentially, kind of the based on the sky dome and kind of mapping, right? Where most of the radiation is coming from. Is kind of how I understand it, and just subdivide it into these little patches. Now, you can change things like this, right? The size, the scale of the sky dome, right? Which corresponds to 100 meters in whatever unit system you're in, things like that, right? So some of these parameters you may use if you're really trying to customize it, but this is just I'm just kind of showing you kind of how to bring it in, or if you kind of want to move, right, the point, move it to the left or the right. If you're doing some kind of comparison like this, then you can just like, okay, I'm gonna bring in a point, right, and I'm gonna make a rhino point somewhere, link this in, set 1 point, sure, and then move the center point, right? So essentially, you can shift this around, right? So it doesn't get in the way of your geometry if you're trying to take a screenshot of it, that sort of stuff, right? So it's this kind of stuff, scaling up and down. That's kind of pretty much it. All right. Now, so that's what this is, and there's nothing else. Okay. Now, the other next step in doing the rest of this is the Sunpath component. So should be under here, visualize geometry, visualize data, LB, right? LB tool, Sunpath. You'll see the windrows here as well. But so that's what this is, okay? So briefly going through the inputs, north, right, of course, 0. So that's the location, coming from location here, right? HOY is coming from your analysis period. Basically, this is kind of, hours of the year, right? So basically, it's like all the different kind of hours that are possible in the year and just like numbered sequentially from like 1 to what, 8,759, or 0 to 8,759. And that's it, right, for inputs. Those are all just those 3 that are really neat. All of these are kind of customization, whether or not you're counting daylight saving time, again, center point, moving things off of the center, blah, 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 that sort of stuff. So it's pretty, again, pretty straightforward, okay? There's only one output here that we generally are using is the vectors, so the sunlight vectors. So if I turn this on, you'll see you get this display, which corresponds to, right, these little dots correspond to the sun trajectories, for throughout the year, right? How it moves, all these sorts of things. And that's all the vectors that are, kind of being used to calculate stuff, okay? Now you can, again, right, with a center point thing, you can move this out of the way, right? So it's kind of by itself if you want to. It gives you the north direction, all this sort of stuff, right? This comes in, and I think the first thing we'll do is analyze geometry, right? So there's 2 of these you can plop in. So direct sun hours, which is this one, under analyze geometry, and then incident radiation, which is this one below, okay? These are the same ones. So the first one here, the sun hours or direct sun hours component. Again, we're just using the vectors that are coming from the sort of sun path coming in, right? The time step, right? I think you can ignore this, but this should be set to, if it doesn't have a value, I forgot, but just give it 1 by default. It generally should be set to 1. It's coming from here, right? Which is like kind of 1 analysis point, right, per hour, right? Okay. Now, geometry and context. So all of these will have a geometry and context input, right? So obviously this all goes back to here, right? Our design geometry, which is your project, and the context geometry, which is all the stuff around, okay? So that's kind of pretty consistent for all of these. Grid size, I would set this to 1.0, at least in this size scale. By default, don't make it a really small number, otherwise it will take forever for it to calculate. But this is kind of like the resolution or density of the analysis patches that you'll see. Parallel, actually, if most of you should be able to toggle this to true, meaning that if you have a quad core, 6-core computer, then we'll use all your computing threads, parallel threads, to actually do the calculations. We can speed things up a lot. It just means that your computer will like pause or hang for a second while it calculates things. Run toggle actually just runs it or turns it on, and I'll explain this later. So what you'll see is that, if I zoom back here, what you'll see is that given the time, and as soon as I double click this to true, right, it will kind of be unresponsive for a second, and we'll have to kind of wait for a couple seconds while it's like running, and maybe like 30 seconds or something as it kind of calculates. It'll be longer kind of the first time, okay? Now I'm going to turn this on. So what you'll see is that you'll see this kind of matrix, right? One thing, if your view display is different from mine, I have going to display here up on the Grasshopper thing, I have my preview mesh edges turned off, but the mesh edges like this actually shows you the grid size. So at 1.0, this is the size of its analysis, right? The granularity. So if you want these to be kind of higher or more detailed, then you tweak this number, right? Going down. So like if you go to 0.5, then it's basically what kind of quarter these, right? So the grid size is 0.5 instead of 1, so it's a lot more detailed. Although if you go too far, like I said, it will take a while to calculate. Okay. Now the other thing, and this is the only reason I have this stuff here, is in the outputs. There's several outputs, but the ones you care about is the mesh, which is this colored mesh output, right? That will overlap with your Rhino geometry for the moment. Has a little bit to do with this offset distance. So this is kind of a minuscule distance to offset some of the coloring so it doesn't kind of run into or overlap with your Rhino model geometry, just so you can see it. So you can tweak this if you want to. I think it's set to 10 centimeters by default. You can make it bigger. But the other reason is this, so like for the legend, which actually you will be able to see if I look at from below the sky right here, that shows you the kilowatt or the sort of accumulated sunlight hours. The reason I have this here is just so that I'm using a move component, right, linked to a z vector, a unit z vector, and a multiplying factor, so that let me turn this on, so that I can move the legend, right, from basically overlapping with a ground plane to wherever, right? I'm just moving this so I can see it. That's all. I mean, you can do the same thing, right? You can move it up, move it to the right. I don't know. It's kind of totally up to you, but it's just that it happens that when it overlaps into the ground plane, it just disappears and you don't see it unless you turn the site context off, which can be a way to do this. But I think I found like 0.1 to 0.2 generally is enough to get it clear, so you can see it. So this is cumulative sun hours, 3,000 hours, 300 hours around here, right? Because it's shaded by this tower right in front of it. Okay, so that's direct sun hours. Pretty simple. Now its counterpart down here, so incident radiation, right? So let me turn this on. Again, right, all of these inputs are the same, right? It's coming from this. So this one, instead of vectors, right, this links to sky matrix output over here on the sky matrix, right? So just like generally with working with these is just, you look for, right, the right names that you need to link up, right? So sky matrix, geometry, context, all the same, grid size the same, parallel, right? Use it, double click this to initiate the calculation. This one's a lot faster because it's kind of run before. So same thing, I'm using the same thing to kind of bring up the legend out, and kilowatt hours per square meter, right? That's the kind of number, how much incident radiation those surfaces are getting, throughout the year, right? Right now, just remember, right now my analysis period is the entire year here. Okay, so those two are kind of very similar and should be pretty straightforward. Okay. All right, now there's a couple supplements, and so these are all kind of essentially the same, or kind of the parallels, right, to the ones in the legacy kind of version. I'm going to bring in a couple here that are kind of newer things. So this view percent, let me run it as well. Okay. And I think, yeah, the legend for this thing is below too. So all you gotta do is copy paste, bring the legend up, and make the last component visible, right? So this is a view percentage. Its sort of description is essentially how much of the sky in terms of percentage, how much of it can be seen from the input geometry right through the context. So you can kind of see like the topper portion of the design, right, gets a bit more, a lot more kind of percentage, right, 60-ish, right around there in the coloring of the sky as a view, right, as a view percentage. Well, down here, once it kind of gets more occluded by some of these surrounding geometry, you kind of fall into the 20s to 30s around here, right? So that's just kind of an interesting kind of way to look at massing. So that's a newer thing. This is the view percent, right? So I should be under analyze geometry view percent. And that's what this component is. Okay. Up here, right? So same thing, analyze geometry visibility percent. That's what this one is. Okay. This one actually can be paired with the legacy component, the LadyBug view rows. So that's why I kind of say this, right? From the legacy version, I think on the legacy version, if you have it, it would be under extra. I think over here, basically number 6. Oh no, that's the shadow study. I forgot where it is. environmental. Okay, here it is. Okay, so it's under number 3 for the legacy version if you have it installed in parallel. If not, then you don't. But this is what it is. And this input is similar. If you've seen the legacy video, then it's the same. But so the context, right, obviously comes from here, right? Context geometry. That's it. The plane, this is the test plane, and basically I link this to that one viewpoint that I put in, right? So right now it's this point, and let me turn this on so you can see what it's doing. There's a radius, which is based on like whatever units you're kind of working in, right? So it kind of basically does an occlusion test based on your surrounding geometry. So the radius, right, controls how far it goes, right? So it's a view analysis. And if I move the point around, then it will kind of update based on, right, what it's seeing, okay? Now, I moved it up, right? So you can kind of put this wherever, like maybe it's pedestrian level, right? Just don't put it below the ground plane, otherwise it won't do anything, right? It just might be how like, above your ground plane, probably ideally at pedestrian level, that's what kind of what you're looking at. Or if you're looking at a certain point, right, up in your kind of site, for example, if I'm just roughly, right, snapping to, right, the corner of my, whoops, the perhaps the top corner, right, of my project, if I'm trying to figure out, well, what can I see if I'm kind of up here, right, you can snap to the point, and then, right, it will give you that analysis as well, okay? So the plane is actually just linked directly to the point, right, because the point basically defines the horizontal plane that it's working off of, okay? Now, as part of that, I'm going to move this down because it works better for this example. As part of that, so this is a legacy component. The newer one here, which is the visibility percent, right, under analyze geometry, visibility percentage, takes that same viewpoint. So that's why there are two coming out here, one going to legacy, one going to the newer one. All this is the same geometry, context, grid size, max distance, right? You have to set the geometry block here, right, to true. So it will basically calculate things that are in the way. Parallel again to true, right? So you'll use all your cores, and then you can just toggle it to run. And I'll turn it on. And kind of what it does that's kind of interesting, like it actually pairs with this. You'll see that essentially it uses the viewpoint and kind of shoots rays out from them. Let me bring the legend in as well. Copy it over and move this over, Q. So in terms of percentage, right, it actually does like basically a percentage of like how much of this is visible from that point. So, all this red stuff is basically kind of invisible or not seen when you're standing here. This front face is 100%, that's what you see, right? So it's more interesting if I kind of start to move my point to like here, right? So what you'll see these two overlap, right? So when I'm literally at this point, most of that blue stuff is what I see in a swath, right? And it actually will coincide with the view rows. So it gives you a kind of visual, right, parameter or visualization of like what really is kind of more directly visible, right, from specific viewpoints of your project, right? So the view rows is more about the context. This is more about like what can be seen, what parts of your design, right, can be seen from specific points. There might be some small kind of deviations because of the way it calculates some incident angles. So, but that's kind of interesting. So those are two kind of view dependent things. Okay. Now down here, I think I mentioned this earlier. So analysis period, right? So that's let me see here, right? Number 1 and the third one down. This analysis period just kind of pretty straightforward, and you can just hover at start month, so months numbered 1 to 12, start day 1 to 31, start hour 0 to 23, end month, end day, end hour, right? So it should be pretty straightforward, right? The only other extra is here. This one is slightly different just because it's the legacy component that does the shadow study. So if you have a legacy version, then it's here under shadow study, right? So like the very number 6 shadow study. I think this is sort of like an in development test thing. So in certain cases, if the shadows get too complex, or there's a lot of kind of casting going on, it kind of wants to fail, but you'll see that. The input here is again a brep container where I just link all geometry. So it's like everything, ground plane, your design, your context in just like one bag. You just put everything in. I copied these two from above, right? So this analysis period is the same one as this one, right? Everything's kind of the same. I just needed isolated because this component generally works with like one Sunpath vector, basically one point in time at once, not a cumulative thing like the radiation analysis, right? So an easy way to check is to just kind of drop in a panel, right? So like this, this should be a single number, right? So not our number 5,267, which is, August 8th, 11 a.m. August 8th, 11. That's why I changed these to be identical, right? They're the same, just to kind of force it into like one time. What you should get is also the vector is a single vector. So there's only one vector value here, right? And that's what goes into the sun vector, okay? That's it. And that's what I'm getting in terms of this projection, right? So there are two things that come out of it. So one is the shadow. These are outline curves. So if you want to isolate them, go to your geometry tab, right? Oops, not a circle. Pull in a curve component here, right? So you'll get that. Out of here, the shade. So this is putting in, you can put in a brep component like that. So I think it's hidden because of my overlapping ground plane geometry and stuff. So I can just like hide it for a second. But there is a sort of brep, or actually because I'm in shaded. No, I am shaded. Okay. Let me try mesh here. No, oh, it should be brep. Yeah. So brep there. So this one shows you, right? Again, if I hide my rhino geometry, you'll see those are the faces that are in shade at this point in time, right? So one gives you the shadow outlines, one gives you the shaded sort of portions, the faces that are in shade, okay? Well, I did say that like it's a little bit prone to failure when the shadows get maybe a bit more complicated. So it's like once you start to get some like weirder overlaps, let's say, let me try 4 p.m. Or sorry, that's 4 a.m. I should try something. And every time I change it, this kind of has to recalculate for a second. So we'll wait for that. So in this case, it failed because it was 4 a.m., right? In the morning, there's no sun at that point in time. So I should do something like 16, which is 4 p.m. And I'll change the end hour, right, to 16 as well. Let's see it kind of. So it's still giving me trouble there. And usually, that happens. Oh, let me. So I'll disable it, enable it again, just to see. Okay. Yeah, so like you'll get this sometimes, math range error. And if you actually look at the README, it'll say one complicated case, right? And that's fine. I think that's just kind of the component kind of crapping out because some of these longer shadows start to cast on multiple things, and it starts to fail. So I think what generally will work, just as a case example, it'll work better, I think, like I had earlier around 11 a.m. or like 2 p.m., you know, something like that. Will be a bit easier for it. Okay, I think that kind of covers everything. I think just the newer version, and so that comes out, right? The newer version, some of these components are just kind of more streamlined. The inputs and outputs are a lot simpler to kind of read and understand and put together. Okay, yeah, so that's it.